So in this video, we are going to use function notation and we're going to find indicative values from either a graph or a table. And so notice that we are given a table of values. The x coordinate is on top. So these are the x coordinates in this top row. And then the corresponding f of x coordinates, which you know that's another word for y, are on the second row. So the top row is our input values and the second row or the bottom row is our output values. So they are asking us to evaluate f of 9. Just a reminder that with function notation, when you have f of 9, that means what is the output when the input is 9. So evaluating f of 9 means find the output value when x is 9. And so that's right here, isn't it? This is our order pair, 9, 12. So that's telling us that f of 9 is 12. Part B is a little bit different. It says determine x when f of x equals 27. So that 27 now is our output, and we are finding the input value that will give us that output of 27. So taking a look at the table, where does that occur? So we're going to look for an output value of 27, and that's right here, isn't it? And the x value that gives us that will then be 12. So be really careful with that because see how sneaky they are here? We've got another 27 in the table right at the end here of the top row, but remember that's an x value and we were looking for a y value that was 27 so that we could find the corresponding x value. Okay, let's look at some graphs. Okay, now in example number 2, we have a graph that represents the function f of x. And I know that you can tell that this is a linear function. This is a line like we did earlier in the chapter, right? So this is a line or a linear function. And we are being asked to evaluate f of 2, which again, a reminder, that means we're looking for the output when x is 2. So we are looking for the output or y coordinate when x is 2. So we're going to go to the graph to an x of 2 and locate the order pair that corresponds to that x, which is right here, isn't it? And we know this as the x-intercept. Turns out that that's the x-intercept. So that means that f of 2 is what number? Yeah, f of 2 is 0. And because that corresponds to the order pair 2, 0, which is our x-intercept, and again in function notation, this will be your input value, and this is your output. Now in B is different because they want us to determine the x, so we're looking for an x-coordinate when the y-coordinate is -4. See? Remember that this f of x also could be called y. So determine x when y is -4. So now I'm going to go here to the vertical axis on the y-axis. I'm going to find -4 and then I'm going to go over to locate the point that goes with that, -4. And now I'm looking for the x-coordinate. And so that x-coordinate is -2. So x equals -2 when y is -4. You starting to get that idea? Okay, well then look at number 3, and I'm going to have you pause the video, quickly give the answer, and then I'll pause and we will talk. We will look at my answer and compare. Okay, so pause your video now. Okay, so in part A, we are asked to evaluate f of 4, which basically means that when x is 4, what is y? And so I went up here to the exponential function. By the way, this is a decreasing exponential function. So we went up to the graph and we located where x was 4, and that's the purple point that I have here. And notice then that the y value is 1. So f of 4 is 1. Now for part B, we were asked to determine x when f of x is 4. So in other words, we've been asked to find x when y is 4. And so I went up here to the y equals 4 on the y-axis and located the order pair there that was -1, 4. So f of -1 is 4. So x equals -1. How did you do?